All right, my name is Joseph Ennis. Thanks for clicking on my video. So this was for my individual project. I made a digital ruler and a level, and this is for Professor Schelke's MEEN-1000 class. Date is April 26th, 2023. So this is what the device actually looks like. It has 3D printed housing, as you can see. It's all the blue stuff. It has a OLED screen on the top here, distance sensor to read the distance, as well as a bunch of other electronic goodies inside. So this is what it looks like in use. So it reads the angle, top, and then below is the distance in centimeters. So pretty straightforward as far as using the product. Pretty much you plug it in, it starts displaying information. So very easy to use, very straightforward. I actually have a video here of the product in use. So as you can see, as it tilts, the angle is going to decrease accordingly. The distance is also going to change accordingly. There's a water bottle right there, which is why it says 6 centimeters. So yeah, pretty straightforward to use. It just displays the angle and the distance as soon as it's plugged in. So the functions of this device, like mentioned, it's to display information about the angle of the device, as well as the distance in centimeters simultaneously. So yeah, I mean, you're putting, assembling something, set this on top, boom, instantly gives you the angle, let you know if it's how flat it is, or how far it is to something if you're looking to measure the distance. So some of the constraints, it does have to be relatively simple design, easy to manufacture. I'm not an expert in this, so the design was somewhat bound to be simple, which along the same vein means that it's pretty easy to manufacture. All the products, or all the components of the product, are mass produced. You can get them on Amazon or really anywhere, and I'm pretty sure you can get them in most countries as well. So easy to produce, compact size. I'll go over the hardware here in a moment, but it does have to be somewhat small, as no one wants to lug around a backpack-sized item to measure distance and angle when they can just use a protractor. Also has to be easy to use. No one's looking to jump through a bunch of hoops just to read information. So yeah, easy to use. That was another constraint. So I feel like the affordability, the price could definitely drop if we mass produce this product. Yeah, I found that buying the sensors in bulk dramatically dropped the price. I feel like it is pretty compact size. Could be smaller in future designs. Definitely easy to use. You just plug it in and read the information. So this is all the hardware and the pricing and everything. So the Arduino board itself, this is what runs the code. Everything ultimately wants to be connected to this to transfer information or all that good stuff. So the multiplexer, what this does is the gyroscope and the OLED both use I2C connections, which are the SCL and SDA pins on the sensors. And the Arduino board, they only have one set of those, the A4 and A5 pins. So obviously can't connect both of them to the board, so I had to get a multiplexer. This essentially just converts the readings into digital. Also has a bunch of channels, so I can connect the OLED and the gyro to the multiplexer connect the multiplexer to the board, and the board can switch back and forth between them accordingly. So the distance sensor, this is just the standard one that comes with most Arduino kits, you know, the blue board and everything. The OLED, this is actually I bought this one because it has to fit 2 lines of information essentially. So I bought this OLED because it was a little easier to fit all the information on the screen. Power supply, so all of these use power, the multiplexer, distance sensor, gyro, Uno board, so I did have to use a 9-volt battery and a power supply to power those, about 16 jumper cables to connect everything, and a 3D printed housing, which I did get done through SLIC, Salt Lake Community College. Shout out to Hovind, so that's why there's not a price for that one. So this is for the actual hardware, or the 3D printed housing, I should say. Everything's in inches here, so we were talking about the compact size earlier. It's about 2.7 inches wide, 4.5 inches long, and then 2.5 inches tall. So it's basically like maybe a little wider than a phone, but basically about a phone if it were a cube, to give you an idea of the size and everything. So yeah, and then as you can see, we have just some windows cut out here during the 3D printing process for the sensors. So this is for the screen, that's for the distance sensor. So these are all the hardware connections. This is the multiplexer, so OLED is connected to this, gyro is connected to this. This also uses power, so this actually is connected to the board for power, digital pins, which it converts everything to. And this is for the gyroscope, so this connects to the multiplexer as well as the 3.3 volt from the board for power. So the distance sensor actually just uses the normal pins for the trig and the echo, and then gets 5-volt power from the power supply here. Yeah, so everything's connected. I opted into no breadboard because I wanted to make sure everything is as compact as possible and the housing could be as small as possible. So that's why I opted into this design. Obviously this looks kind of messy, but it works, everything's connected together. So this is what it looks like inside the device. So as you can see down here, we have the multiplexer, the gyroscope. This is actually taped to the wall to make sure that the yaw is steady, which is ultimately basically what's ultimately going to give us the angle, because we only really care about that one aspect of the gyroscope. So I wanted to make sure it's really flat in the direction that the sensors are facing. So if I move it up this way, the gyroscope moves so that the yaw is increasing. And as you can see here, the screen connected directly to the cover of the 3D housing. Pretty straightforward. There we go. This is for the code. So these are the libraries I used. This is for the OLED. This one's for the gyroscope. This one's for the distance sensor. This is all just setup stuff. Setup for the gyro library. Setup for the multiplexer. You know, defining the address, the channel, all that good stuff. Defining the trig and echo pins for the distance sensor. This is the initialization. So as you can see, I really just went through it one piece at a time. So set up this, set up this, set up the multiplexer, set up the distance sensor, initialize everything, initialize the screen, initialize the gyro, initialize the multiplexer, initialize the distance sensor. Really just broke it into sections because I found out that was the easiest way to do it. So yeah, and then for the loop itself, basically we're just reading. This is also broke up into sections. So this one we're just reading the gyroscope, creating variables out of all the X, Y, and Z information, and then using tangent and converting it from radians to degrees. Gives us the angle in degrees. Similar for the distance sensor, we're just reading the pings, how long it takes, which is this duration, how long it is between pings, and then I just basically set up the sensor with a ruler from like 20 centimeters away, and then just multiply the duration by what it takes to make sure the reading is correct. So you can adjust that yourself. And this is for the screen, so basically just printing everything to the screen, and I added a 1-second delay before we got more measurements and updated the screen, just because I thought it was a little easier to read everything in the long run. So yeah, that's code, pretty straightforward. So the importance of this product, as well as I think where the product excels, is first with the importance is everything is, built, designed based on information from the world around us. So this product could be used to develop other products. It could be used for people in a profession that are building things. Woodworking, construction, just to name a few. People, even if their profession isn't something that requires putting things together, design, people still put things together or need information about the world around us. I mean, a classic example for a level, for instance, is putting up a picture rather than, struggling, trying to figure out if it's even, setting it up, stepping back, adjusting it, stepping back. You can just set it up and set this on top, move it until it reads 0, and then you're good. So yeah, there's tons of applications for this. For me, even itching that curiosity, you pull over on the side of the road, set this down, it gives you an angle of the road, just because you wanted to know, because you're curious. Ski slope, same thing. You can put this in your bag. When you're skiing, you just set it down on the ground and it can give you the exact slope of what you're about to ski down. So tons of applications. The physical world is pretty important when it comes to designing things and our experience. So information about the physical world is always very important. I may be biased because I want to be an engineer, but still. So the efficiencies of the design is it's very easy to improve, I think. Obviously, there will definitely need to be improvements, which we'll get to here in a second. So can improve the design. I think it has the capability of being an everyday item, something that you can put in your toolbox, or get it small enough you can put it in your purse or your pocket. Boom, set it on the ground, gives you the information. So very easy to replace the parts and maintain. Everything is pretty much I don't know, compartmentalized. I don't know if that's the right word, but broken into different sections. So if you have an issue with one thing, you can easily replace it. Yeah, easily repaired, I guess is the best way to put that. It's also easy to produce because of this. All the parts are mass produced, so they're available in most countries from what I could tell. Very easy assembly. like I mentioned earlier, wide audience, everyday people to professional applications. Um, yeah, so I just think this would be a great product to invest in, a lot of upside, very easy to use, not a whole lot of complication there. So aspects to improve. Gonna be honest, this list looks pretty long, but this is if we are looking to, um, manufacture this device. We would probably need complete battery power. Realistically, nobody's going to want to have to plug this into their computer in order to get information. So that is a must. Some wire sorting and some soldering. This would be important just for the manufacturing process, as well as the overall reliability of the device. Some of those pins, especially the female ones on some of those boards, can get a little loose. So definitely look into soldering everything together to make sure all the connections are pristine. Even smaller design probably would be ideal. You could use a micro Arduino. You could also look into getting smaller distance sensors, because that's, in my opinion, the biggest sensor. So yeah, just smaller products, shrink everything down, would be ideal. Like I mentioned in the other slide, something that you could fit in your toolbox, pocket, purse, stuff like that. So charging capabilities, yeah, this isn't required in my opinion, but could be something that could be looked into. Rechargeable battery, you could also just use replaceable batteries. Also a larger, more visible OLED screen. So the screen is very difficult to read. Very small. Obviously, if the design got small enough, you could probably keep the design the same. But I would want something a little more visible. I tried increasing the size of the font. It actually just ended up cutting off the information. So on and off switch. So this would be important for the design. Right now, you just plug it in and read the information. Obviously, if we're trying to ditch the plug completely, it would need some sort of on and off switch. Along with that, you could add another button or a switch that converts, switches between metric and imperial measurements, inches and centimeters or millimeters or whatever. And yeah, you could add 2 buttons, and I think the design would still be very simple, very easy to use. Just label it on, off, metric, imperial, boom, done. So just want to go over my experience with this project altogether. So I chose this project because I wanted to design something that I would actually use quite a bit, something that wouldn't be pushed off to the side as soon as this is finished. So I wanted something that I could use for, my final capstone project for my degree, or future jobs, or like I mentioned earlier, even when I'm just curious about the world, skiing, I want to know the slope of something, or when I'm building something silly at home, I can get all the information about the angles and the distance to ultimately create a better design. So I guess why I chose this, like I mentioned before, maybe a little biased because I'm an engineer. I really just wanted to have something that I could use. Obviously, I think even for me to use it regularly, I still would need some improvements, full battery power, stuff like that, etc. So the most difficult aspect of designing this was honestly the hardware itself. The gyroscope specifically, bought 2 of them, and they both pretty much failed. Yeah, one of them failed. The other one is still not doing very well. I think it's just the brand that I used. Turns out it's a brand that nobody really uses. Found it very difficult to find sample code for it, the syntax for the libraries and whatnot was outdated in a lot of the examples. So I found out that was probably the most difficult part, was getting the angle working. As soon as I was able to get readings, it was relatively easy to display it on the OLED and whatnot. So yeah, I'd say that was the most difficult design. Still giving me trouble, as I mentioned, and aspects that could be improved. The gyro would definitely be up there. So as far as help, a big place that helped me with this project was if you go to the libraries, when you download them on Arduino, you can actually hit more info. Takes you to their website. You can view sample code and whatnot there. So that's where I learned a lot of syntax for the libraries, was through there. Sample code is extremely helpful. Obviously YouTube, a lot of good information on there. So if I could start over, I would actually choose possibly a different design altogether. Something that possibly has a more mechanical aspect rather than, just converting information to a screen. Just because I want to work more with, mechanical properties, physical stuff rather than digital. So that's a big lesson I learned from this. But yeah, overall, I still really enjoyed putting everything together. Wasn't easy, had me pulling my hair out here and there, but overall, it was a good experience. So thanks for watching, and best of luck with your guys' projects.